Hi friends, welcome back to my YouTube channel. So today I'm going to discuss about advanced communication system for the first topic, multiple access. So we are going through the introduction part of this multiple access. So as I think you have already heard about multiple access techniques, TDMA, CDMA and FDMA etc. So we are going to discuss more detail about those multiple access techniques. So this is already an introduction part, so we will be having next sections regarding or each of the multiple access techniques as well. So for your information, this is from module 6 advanced communication system EC404 for the electronics and communication engineering students. So those who are preparing for ACS exam, you can refer these notes and you will get a better marks on that exam also. So we can go to the section. So first of all, as you know, multiple access. So multiple access schemes are used to allow many more mobile users to share simultaneously a finite amount of radio spectrum. The sharing of spectrum is required to achieve high capacity by simultaneously allocating the available bandwidth or the available amount of channels to multiple users. So multiple access means it allows many users to share simultaneously a finite amount of spectrum. So many people can access a band simultaneously. That is the meaning of multiple access. So we can achieve high capacity at the same time. So for high quality communication, this must be done without severe degradation in the performance of the system. So for high quality communication, this must be done without severe degradation in the performance of the system. So in wireless communication system, it is often desirable to allow the subscriber to send simultaneously information to the base station while receiving information from the base station. So in wireless communication, the simultaneous communication needs to be there, like the subscriber need to send and receiver also needs to send some information to base station and the receiving station. For example, in conventional telephone system, it is possible to talk and listen simultaneously, and this effect called duplexing, and it is generally required in wireless telephone system. So conventional telephone system, we can see that we can listen and talk simultaneously. This is called duplexing. So this technique is used in conventional wireless telephone system. So duplexing may be done using frequency or time domain techniques. So duplexing can be done by frequency or time domain techniques. So first one is FDD, frequency division duplexing. So these provide two distinct bands of frequency for every users. And the forward band provides traffic from the base station to mobile, and reverse band provide traffic from the mobile to base station. And in FTT, any duplex channel is actually consists of two simplex channels and the device called duplexer. So it consists of two simplex channels, forward and reverse channels, and a device called duplexer. So duplexer is used inside each subscriber unit and base station to allow simultaneous radio transmission and reception of the duplex channel pair. So duplexer is used in each subscriber and the base station, and it allows the transmission and reception of the signals. And the frequency split between the forward and reverse channel is constant throughout the system regardless of the particular channel being used. So here happening frequency split between reverse link and forward link, so that is a constant. And another technique is called time division duplexing, TDD, used time instead of frequency to provide both a forward and reverse link. So there is also reverse and forward link, and the splitting is happening in time domain, and the time split between the forward and reverse time slot is small, then the transmission and reception of data appears simultaneously to the user. So the split time is very small, then the transmission and reception of data appears simultaneously to the user. So you can draw this picture as well when it is asked for to the duplexing techniques, TDD and FDD. You can draw this one. The first one, figure A, shows the FDD provide two simplex channels at the same time. In TDD, provide two simplex time slots on the same frequency. So TDD allows communication on a single channel, as opposed to requiring two simplex or dedicated channels, and simplifies the subscriber equipment since the duplexer is not required. So as you see, we are using duplexer, the device called duplexer in FDD, but we are not using the duplexer device in TDD because it allows the communication in a single channel. So there are several trade-offs between FDD and TDD approaches. FDD is geared toward radio communication system that provide individual radio frequencies to each user. So in FDD, for individual user, it is giving individual radio frequencies for each user because each transceiver simultaneously transmit and receive radio signal which may vary by more than 100 dB, and the frequency allocation used for the forward and reverse channel must be carefully coordinated with the band users to occupy the spectrum between these two bands. Furthermore, the frequency separation between must be coordinated to permit the use of inexpensive RF technology. And TDD enables each transceiver to operate as either a transmitter or a receiver on the same frequency and eliminate the need of a separate forward and reverse frequency bands. So in TDD, as you know, it's a transmitter because at the simultaneous time, at the same time it can act as a transmitter or a receiver in the same frequency. So it eliminates the need of a separate forward and reverse frequency bands. However, there is a time latency due to the fact that the communication is not full duplex in the truest sense. So most probably in the most major access technique that used in wireless communication system is FDMA and TDMA and CDMA. So FDMA means frequency division multiple access, TDMA time division multiple access, and CDMA code division multiple access. So these are the major techniques used in wireless communication system. So these techniques can be grouped as narrowband and wideband system depending upon how the available bandwidth is allocated to the user. So the duplexing techniques of a multiple access system is usually described along with the particular access scheme. So we can go to the two classification of these wireless communication system major multiple access techniques. First one is narrowband and second one is wideband system. So in narrowband system, the term narrowband is used to relate the bandwidth of a single channel to the expected coherent bandwidth of the channel. So the term narrowband is used to relate the bandwidth of a single channel to the expected coherent bandwidth of the channel. So in the narrowband multiple access system, the available radio spectrum is divided into a large number of narrowband channels. So the available spectrum is divided into a large number of narrowband channels. The channels are usually operated using FDD. So in narrowband system, it is normally operated by using FDD, frequency division duplexing. To minimize the interference between forward and reverse links on each channel, the frequency split is made as great as possible within the frequency spectrum, while still allowing inexpensive duplexer and common transceiver antenna to be used in each subscriber unit. So to minimize the interference between forward and reverse channel, the frequency split is made possible within the frequency spectrum and while still allowing inexpensive duplexer as a common transceiver antenna to be used in each subscriber unit. In narrowband FDMA, a user is assigned a particular channel which is not shared by other users in the vicinity, and in FDD is used, and that is for each channel has a forward and reverse link. Then the system is called FDMA bar FDD. So in narrowband FDMA, frequency division multiple access, a user is assigned for particular channel which is not shared by other user in the vicinity and FDD used. Then the system is called FDMA FDD. Narrowband TDMA, on the other hand, allows user to share the same channel but allocates a unique time slot to each user in a cyclical fashion on the channel. So in TDMA, they are using a same channel but allocates to a unique time slots to each user in a cyclical fashion, thus separating a small number of users in time on a single channel. So in narrowband TDMA, there are generally a large number of channels allocated using either FDD or TDD, and each channel is shared using TDMA. So such systems are called TDMA FDD or TDMA TDD access system. So this way we can represent each narrowband systems. So going to wideband system. In wideband systems, the transmission bandwidth of single channel is much larger than the coherent bandwidth of the channel. So the bandwidth of single channel is much larger than the coherent bandwidth of the channel. Thus the multipath fading does not greatly affect receiving signal within a wideband channel, and frequency selective fades occurs in only a small fraction of the signal bandwidth. In wideband multiple access system, the users are allowed to transmit in a large part of the spectrum. So wideband multiple access system, the users are allowed to transmit a large part of the spectrum. A large number of transmitters are allowed to transmit on the same channel. So TDMA allocates time slots to many transmitters on the same channel and allows only one transmitter to access the channel at any instant of time. So TDMA allocate time slots to many transmitters on the same channel but allows only one transmitter to access the channel at any instant of time, whereas spectrum CDMA allows all the transmitters to access the channel at the same time. So TDMA and CDMA systems may be used either FDD or TDD multiplexing techniques. In addition to FDMA, TDMA, CDMA, and space division multiple access SDMA schemes are used for wireless communication. So the table shows different multiple access techniques being used in various wireless communication systems. So in cellular system, we have advanced mobile phone system AMPS. There we are using FDMA FDD. In global system for mobile GSM, it is used by TDMA FDD, and US digital cellular USDC TDMA FDD, and Japanese digital cellular JDC TDMA FDD. C2 squares cordless telephone, so this is used by FDMA TDD, and digital European cordless telephone DECT is used by FDMA TDD, and US narrowband spectrum IS95 is used by CDMA by FDD. So these are the major multiple access techniques being used in various wireless communication systems. So this is all about the introduction part. So I think we are good with the introduction. We will go inside to each multiple access techniques such as FDMA, GDMA, CDMA, SDMA, and we will discuss thoroughly each of the multiple access techniques in the next sections. So try to watch this video before that, and I will be posting those videos in future days. So if you like this video, please subscribe my channel, like, share and comment. So thank you for watching this video. If you have any doubt, please comment in the comment box, and I will try to put my answers as well. So thank you. Share this video to your friends as well if they want to learn anything about ACS, Advanced Communication System, and give them my channel name TLT, Teaching, Learning and Thinking. So thank you. See you in the next video.